Okay, in a previous video we talked about what expected value is. In this video we're going to discuss its uses in business. Okay, so our objective, use expected value to solve applied or to solve business problems. All right, what do we come in knowing? Well, we know what probability is, the chance that something will happen, and it's always, the probability is always between 0 and 1. We know how to find the probability of an event happening. The denominator is the total number of outcomes. The numerator is the number of ways the event can happen. We know that the probability of an event happening plus the probability of the event not happening or the other events is 1. That's everything. And we know that expected value is the long run average. Okay, and we saw in the previous video the expected value, which we're calling E, is the sum of the products of each outcome times its probability. Okay, let's take a look at a couple business examples, see how this works. All right, let me get this up here. Example number 1. The chart below shows probabilities for various auto claims. Okay, and I have in column 1 here the cost of the claim. These are the outcomes. Okay, so these are the outcomes. And what this says, they're rounding to the nearest $2,000. So this is saying that any claim that is less than $1,000 is closer to 0 than it is to $2,000. And this category includes all claims that are $1,000 up to $3,000 because they'll round to $2,000, et cetera, et cetera, et cetera. And as you can see over here, the probability as a decimal, the vast majority of these auto claims are less than $1,000 because those are the numbers that will round down to 0. And of course, 0.7 we know is in percentage terms 70%. So these auto claims listed here, 70% of the claims that come in are less than $1,000. 15% that come in are between $1,000 and $3,000. 8% that come in are between $3,000 and $5,000. Again, they average to $4,000. 5%, 1%, and 1%. So 1% of the claims that come in are $7,000 or greater. Okay, only 1%. That makes sense. It's a car. How much should it cost to repair a car? Most of our costs to repair a car are under $1,000. Okay, so we have the cost of the claim and we have their probability. Let's remind ourselves that when we add up all these numbers, we should get a 1 because we want to account for all probabilities. All possibilities need to be accounted for to calculate the expected value. And of course, this is, 1 is the same as 100%. We want to account for everything. So let's calculate the expected value and describe what this means. All right, let me shift up a little bit here. Okay, the expected value, let's remind ourselves, is the sum, sum is not spelled with an E, the sum of the products of each outcome times its probability. Okay, so first outcome is the claim that's the nearest 2,000. The claim is a $0 claim. So we have a $0 claim, and its probability is 70% or 0.7. The next, the sum of the products of outcome and probability, so 2,000 times 0.15. So plus a $2,000 claim times 0.15, and then plus a $4,000 claim, and there's an 8% chance of that, 0.08, plus a $6,000 claim, and there's a 5% chance of that, 0.05, plus an $8,000 claim, and there's a 1% chance of that. And I'm not going to have enough space, I don't think, so I'll put it down here. Plus a $10,000 claim, and there's also a 1% chance of that. So again, the sum, these are the products, each outcome times its probability. I do that for all outcomes and probabilities, and then I add up those products. This is a calculation into a calculator, and it comes out to be $1,100 is the expected value. Okay, so what does that tell us? That in the long run, the average cost of a claim is $1,100. Okay, long run, claims keep coming in, and you average them all out, okay, based upon the size of the claim and the probability that it happens, and you can expect that each claim is going to be for $1,100. So, as claims are made, okay, and we're going to say, just more and more, we're going to, in the long run, so not just the first claim, not the second claim, but as claims continue to be made, let's put that instead. As claims continue to be made, the average cost of a claim is going to be $1,100. So essentially, maybe this is an insurance situation. As they're thinking about all these claims that keep coming in, they can expect that the average cost over the long run is going to be $1,100, and then they can plan accordingly. Okay, let's take a look at another example, kind of a construction bid example. Give me a second to set up here. Okay, so example number 2. I think I'm straight. A construction company is planning to bid on a building contract. Okay, the bid cost the company $2,000. So to put the bid in, they have to spend $2,000. So that may just be, putting the bid together, the paperwork together. Maybe it's a construction company. Perhaps they make a model, but it's going to cost them $2,000 to put that bid together so that it's presented to be accepted or rejected. The probability that the bid is accepted is 1 in 4. Okay, a 25% chance that their bid will be accepted. If the bid is accepted, the company will make $40,000. Not bad, but of course, you have to take away the $2,000 to talk about the gain for the company. Okay, so we have to subtract the cost of the bid to get their net gain. What is the expected value in this situation? Okay, so outcome. Well, first outcome is we want to account for all outcomes. The bid is accepted. Okay, they got it. Okay, now you'll notice I put an additional column in here, a gain or loss column, because these outcomes are kind of more verbal or more literal outcomes. What happened? Well, the bid was accepted. Great. What was the result of that? Well, the result of that was a gain, a financial gain or a financial loss. Okay, well, $40,000 came in, but they had to spend $2,000 to put the bid together. So their gain is a positive $38,000. Okay, so their gain, the result, I should say, is a positive $38,000, which represents a gain of $38,000. And what is the probability of the bid being accepted? Well, we're told the probability is 1 out of 4. Now we need to account for all outcomes. Well, the only other outcome here is the bid did not get accepted. So their bid was not accepted. Somebody else's bid was accepted. Okay, well, their bid is not accepted. That means, well, they're out $2,000. So there's a loss of $2,000, which we're going to show as a negative $2,000. The negative means a loss. The positive means a gain. And what is the chance of their bid not being accepted? Well, as you remember, the total is equal to 1. All right, we need to account for all probabilities. And so we have to have a total of 1 once we're done. So we'll take the 1 minus a quarter, and the probability of their bid not being accepted is 3 out of 4. If 1 out of 4 is accepted, then 3 out of 4 is not accepted, because 1 out of 4 plus 3 out of 4 is 1, the total of all probabilities. Okay, now let's calculate their expected value. Expected value is the sum of products of each. Okay, in this case, we're going to look at the gain or the loss, because the outcome in words isn't going to help us mathematically. So I'll say that each gain or loss times its probability. Okay, well, let's take a look at the first one. The first one, the bid is accepted. There's a gain of $38,000. So a positive $38,000. And its probability, its chance of happening, is 1 in 4. And we're going to add that, the sum of the products, to the next outcome, which is a loss of $2,000. I'll represent that with a minus sign. And the probability that it's not accepted is 3 out of 4. So we've accounted for all possibilities, all outcomes. They get it, they don't get it. The outcome, if they get it, is a gain of $38,000. The outcome, if they don't get it, is they lost $2,000 putting the bid together. And the probability of getting the bid is 1 in 4. The probability of not getting the bid, or of the bid going to someone else, is 3 in 4. That's a calculation, and this comes out to be a positive $8,000. So obviously the company, the company wants to take advantage of these opportunities, because they're coming $8,000 ahead for every bid on average. Okay, so in the long run, remember, this is not just one bid. If they do this, if they bid in this situation over and over again, okay, so in the long run, okay, the construction company can expect to earn an average of $8,000. It's positive, so they can earn an average of $8,000 per bid in this situation. Okay, so if this situation continues to happen, they may win the first, lose the second, lose the third, win the fourth, lose the fifth, lose the sixth, lose the seventh, lose the eighth, win the ninth, etc. But when all is said and done, you do bid after bid after bid. In the long run, they can expect that every bid they're going to do is going to net them $8,000 on average. Okay, so there's a business application, or a couple of business applications. In the next video, we'll take a look at some games of chance applications.